Hey there, it's Jason from Codemanship with another belated video diary entry. I owe you a few, so this one might be a little longer than normal. And I've got some code to show you so that we can have a discussion around the subject of modularity and its relationship to certain styles of test-driven development. So I've been working with a client quite extensively over the last 3 months nearly now. And we've been doing the Codemanship Codecraft training, but we've been doing it with a lot more time. Basically, I've been coaching them in pairs, and I've spent a few hours each week with each pair, and that's given us a lot more time to work on a practical exercise. So I invented a slightly meatier exercise, one that's going to take more than a couple of hours, called Jason's Guitar Shack, and I'll post a link to my blog post about Jason's Guitar Shack in the description below. But all you need to know is the basic idea is we're building an application that sends alerts when products in our Guitar Shack need restocking. And in order to do that, we need to calculate when they've reached a certain sort of minimum stock level, a reorder level. So when every time we make a sale of a product, we check to see whether or not that reorder level has been met. And then if it has, we send an alert to the manager to tell the manager that they need to order more of that particular product. The idea being that we don't run out and then spend days or even weeks waiting for new stock, because that means lost sales. So that's the basic idea. And I've just had a go at it this morning. So I've spent, let me just get rid of my unused imports here. So I've spent a little bit of time having my own sort of little go at it this morning. And the way that I've approached it, doing test-driven development, of course, is working from the outside in. And I've been using stubs and mocks as placeholders for other parts of the design. And that allows me, working from the outside in, from the sort of entry point to our logic here, to fake it until I make it. For other parts of the design, other problems that need to be solved, so I can focus on solving one problem at a time. So I started writing tests for a thing called a stock monitor. That's the outermost object, that's the entry point to our system. And the stock monitor receives notifications of products sold, like that, and then internally it does some work to figure out whether or not we need to send an alert. So we've got a mock alert here, and we're checking to see whether its send method is called for the right product. Now, there's a bunch of other problems that need to be solved in order to do that. We need to know what the reorder level is. That needs to be calculated, and it's calculated using historical sales data. So it's a non-trivial thing. We're not just providing a number, and we need to go off to the web, fetch sales data, historical sales data for that product from a web service, and then do a little calculation with it. So we also need the product's details, and those, again, that's not our data, that's coming from an external source, from a warehouse system that contains information about the product, in particular its stock, the manufacturer's delivery lead time, and other stuff that we would need to know in order to figure out whether or not we need to send an alert to the manager to reorder that particular product. So we've got this sort of fake warehouse here. These are all interfaces. We can take a look there. So that's an interface. The reorder level is just an interface. Of course, if we were working in Python or JavaScript, we wouldn't even need the interfaces. Alert is just an interface. So those three collaborating objects, the objects that Stock Monitor is using in order to do its job, we're faking them until we make them. So I started there, and we wrote a little test for our Stock Monitor, and then we take a look inside Stock Monitor. We can see that it's using the warehouse to fetch the product. It checks to see whether the product needs reordering by comparing the stock minus the quantity sold, so how many will we have in stock after this sale. And then it tells this reorder level object to calculate the reorder level for that product. Fairly simple stuff. So that was like the first sort of entry point into our design. And then I worked my way in and started writing tests for the reorder level implementation. So we've got a lead time based reorder level here, this implementation. And so I wrote a test for this, and that also needs information about the rate of sales. How many of that product do we sell each day based on recent sales data? And we fake that until we make it. So we just have an interface for that, and we stub that. And then when we've got the lead time reorder level implementation working, again, I work my way in and say, okay, we need something that calculates the sales rate, and that's based on the 30-day average of sales. Okay, so again, we need to calculate the sales rate. That needs the sales data from that external source. So we fake the sales data, basically, recent sales. So we define an interface for getting recent sales so that we can stub that in our test. So we're mocking and stubbing all the way down. Working inwards from the outside, one layer of a design at a time, using test doubles so that we can solve one problem at a time. So that's a good reason to use them, so we can fake things until we make them. And I did a similar thing for the warehouse for fetching the product information. So we've got this warehouse information interface for getting products. And then we do an implementation of that for our product data. And then there's some web stuff, a REST client at the back. And again, we fake that to just return hard code, just to work with hard-coded JSON so that we could unit test as much of that as possible. There's our REST client. The REST client, again, we're still faking it until we make it. So we do some work in the REST client to essentially fetch the everything. Now, there's some refactoring that went on here as well. So originally, this REST client was considerably larger. It was doing more. It was building the HTTP request, retrieving the response, deserializing it, and all that kind of stuff. And I refactored that, and I extracted a class for building the request. And this network class is just an interface. So again, we're faking the network until we make it. And then finally, at some point, where's network? There you are. There we go. So we can just stub that with hard-coded JSON strings so we can test all of that. And then finally, sort of at the back end of our system, at the bottom of the call stack, for this network, we've got, where is it? We called it the web. There you go. That's our network. And that's just connecting with an HTTP client and retrieving whatever response we get. So that's how I did it, working from the outside in. My intention was to use stubs and mocks as placeholders in the design so that I could solve one problem at a time. And what I've ended up here as a side effect of doing that is code that is highly modular. Each of our classes, there's a class that does one thing. There's another class that does one thing. There's a class that essentially does one thing. It makes a decision and then sends an alert. There's a class that definitely doesn't do very much at all. Just a data class. There's our sales data class. That's probably the largest one there. Now, I could argue there's a bit of refactoring that needs going on here with formatting dates and that kind of stuff. That's just Java dates, nasty stuff. But it's really only, if I were to refactor the date stuff out, it would be doing one thing. There's our REST client, that does one thing. And there's our request builder, that just builds the HTTP request from the URL. So as we go through it, there's our product data and so on and so forth. There's just another data class. And there's our lead time reorder level. So each of our classes is doing, at most, one job. And all of the dependencies, for the most part, in our classes, I say all for the most part, that's a bit of a contradiction. Most of our dependencies are swappable by dependency injection. So the sales rate, for example, for our reorder level calculation is being injected into the lead time reorder level implementation. If we take a look at our product data there, okay, if we take a look at our product data there, our client is being injected into the product data object and so on and so forth. So we can kind of see that pattern repeated all the way down. All the dependencies are swappable. So all of our modules are doing one job. All of our dependencies are swappable. All of our modules are hiding their internal details for the most part. I make one exception with product. We got a little bit of feature envy going on with product, but that's because because product is a data class that's retrieved from the web. I just figured that was probably the easiest way to do it, and it's a tiny amount of feature envy, so I'll probably just live with that. The rest of them are hiding their internal workings, and it should come as no surprise that they do. Maybe the biggest reveal here is if we take a look at the interfaces. Each of our interface just has one method on it. There we go, like that, one method, one method. So there's a clue that they're all doing one thing. But the reason they all have one method is because I know what I want them to do. I want to be able to tell them to do this. But I don't know how they're going to do it. And because I was faking them until I made them, that means I didn't know what the internal details were going to be. I didn't know what the inner workings of these implementations were going to be. I just knew that I wanted to be able to tell them to do something. So I've kind of quite naturally ended up with a design that is in the style of tell, don't ask, as you would tend to do when you are not intentionally hiding the internal workings of a class, but you're actually deferring those internal workings. You say, well, I'm not going to think about how it does it. You just design a very simple interface. You define a very simple contract for telling it to do its job. And so you end up in a kind of tell, don't ask style of architecture where the details are hidden. And let's take a look at our sort of test suite here. We've got different kinds of tests. So I've got a bunch of unit tests. First of all, let's run these unit tests with coverage. So I want to show you something here. So this is code that has non-trivial external dependencies. It's connecting to real web services to get its data. Let's run these with coverage and see what kind of, how much of our code is actually being tested by the unit tests. Take a little while, having a little think. Okay, let's add that to the active suites. Okay, we've got 100%. That's not what I meant to do. Let's try it again. That's just going to do it normally, isn't it? Okay, that's better. So we've got 91% line coverage from our unit test, and 91% of our code, 95% of our methods are covered by unit. Let's see which one isn't. No surprise, everything's being unit tested apart from that web class. Let's take a look at the web. The one that actually connects to the internet is the one little block of code that's not being unit tested. So because our code is very, very modular, because we're using stubs and mocks and using dependency injection throughout the design, it's very, very easy to test most of our code without actually connecting to the web. So we've got high unit test coverage there. We could probably go even further and strip that line out into its own class and just mock that and get 99% coverage, but that's something to think about. So we've got high unit test coverage, so that's a good thing. We have, of course, if I run all of the tests, let's run those with coverage, and we would expect to get 100% coverage because I've been doing test-driven development. And okay, there we go. Yeah, 100% coverage as you would expect. Now, there's two other kinds of tests that I want to sort of introduce you to here. The first one you'll probably be familiar with. These are integration tests. So this is an integration test for our stock monitor where most of it is built using the implementations. There's only a little bit that's faked. So I'm faking today's date because we want the date to be repeatable. And that's another good reason to use stubs and mocks. Let's just move that down a level there. And what else is fake? Well, everything else is real apart from our alert, which is a mock object. We haven't built that yet. I don't know how I'm going to send the alerts. And we're just verifying for the test data that I chose from the real systems, that alerts should be sent based on the data that I chose. So that's a proper integration test, and that's touching a large amount of the code just by itself. In fact, if we just run our integration tests on their own, where are we? Run those with coverage. Okay. That's not very helpful, thank you. What have we done here? I'm just going to quickly, not really keen on the built-in coverage tool in IntelliJ. Bit of a pain. Okay, let's try again. So we would expect an integration test to give us very high coverage because its purpose is to touch as much of the code as possible. So how much code are we not touching? Not all of product. Okay, that's interesting. Not all of web. Well, if it's connecting to the web successfully, that means that our unhappy path for web connections is not being exercised. What parts of product are we not using? So we're not using the product ID. That is surprising, actually. That's very surprising. Why are we not using the product ID? Anyway, I'm not going to think about that at the moment. So we get high coverage from that single test because the real purpose of an integration test is to touch as many parts of the code as possible. We're not actually testing the functionality necessarily, we're just testing that when we plug all these implementations together, that it actually works as a complete sort of system. And again, we shouldn't be surprised that it works as a complete system, even though I've written unit tests and sort of test-driven the individual pieces of the jigsaw, and then wrote this integration test last. So this was the first time I put it all together, all the pieces together. Not at all surprised they worked first time, because those pieces, their design was driven from the outside in. In other words, we defined a contract first, and then we created an implementation for that contract. So we shouldn't be at all surprised that all the pieces of the jigsaw fit together, because we defined their shapes to fit perfectly into the client code, working from the outside in. You'll notice something else. I've kind of formatted my code, as you'll see, so to make it a bit more obvious what the call stack looks like and how it's composed. So our stock monitor is composed of an alert. It's composed of product data, which is composed of a REST client, which is composed of that web object and a request builder. And its stock monitor is also composed with a lead time reorder level that's composed with a 30-day average sales rate, which is composed with a sales letter object, which is composed with the REST client, which is composed with the web, and so on and so forth. So we can see how our objects, our call stack is composed from the outside. This is what we call inversion of control, and it's very obvious to see it. And particularly when it's sort of justified like this, when we've got it sort of laid out in this little cascade, it makes it a little more obvious that what we're essentially doing here is what I call Russian dolls. We're injecting objects into objects, which are being injected into objects, which are being injected into objects, to create the call stack, as it were, create the call stack dynamically from the outside. And it's only possible for us to do that because we have highly modular code here, because we have modules that are only doing one job. We've got modules that are hiding their internal workings. And very importantly, modules with dependencies are swappable. These modules are interchangeable very easily. So I can fake today's date, or I can fake sending the alert. I can fake any part of it I want, or replace any part of it I want with a different implementation. I've got all these different flex points in my design as a result of working in this way. So it should come as no surprise to us that working from the outside in a test-driven way, using stubs and mocks to fake it until we make it, essentially using them as placeholders for parts of the design we're going to get to, which allows us to solve one problem at a time, where we quite naturally end up with highly modular software, which is also nicely highly tested, and most importantly, highly unit tested. More than 90% of the code is being unit tested. So that's the kind of point I wanted to make. And the reason I wanted to show you this example is because in the video on modular design, I do a much shorter example. I think it's probably a bit more obvious with a Meteor example, an example that's a little less trivial, where there's a bunch of stuff going on. And also that's a bit more business oriented with actual external dependencies, so you can get a feel for how that actually works. Now, there's two other test fixtures left that I've not mentioned yet. And these are my contract tests. Well, that's the one in particular that I'm going to show you. What is a contract test? Well, what I'm doing here is I'm using an abstract version of a test. So I wrote a test, a unit test for testing the sales data object, the object that connects to the internet and fetches the JSON and deserializes it and presents us with a sales total for that particular period of time, that recent sales data. And I've got two versions of this test. So there's one version, and we've also got a unit version. There's the unit version of the test. And let's take a look. We've got somewhere in here, a base test, which is neither fish nor fowl. It's not a unit test or an integration test or a contract test. It's an abstract test, essentially. It's a test where I've got the test method inside my abstract test class here, and I'm abstracting how we're getting the back end. In other words, we can vary how we create the back end. Which implementation of network do we use? Do we use the real one that actually connects to the web? Or do we use a stub implementation that returns hard-coded JSON, and that allows me to unit test it? Or to test it with the real back end. Now, why would I want two versions of this test? Well, one, because it means that a lot of code inside that integration code is being covered by unit tests, but also it means if the unit test is passing and the contract version of this test, the one that actually uses the real web connection, if that suddenly starts failing, it strongly implies that something has gone wrong at the other end. And those are very useful kinds of tests, because not just for me, just to warn me that maybe, for example, the people from the sales looking after the sales system have changed the API or something like that. But it would also be quite useful for the people working on that API to be able to run my contract tests, so they can get a feel for whether or not changes they're making are actually potentially breaking client code. If you've got lots of client contract tests failing, so you might be able to rig this up so they can actually run just your contract test, which are really just highlighting the difference between whether or not it works without connecting to their API and whether or not it works when we do connect to their API. And like I said, if the unit test is failing with the hard-coded JSON, but for some reason the contract version of that test, if the unit test is passing, but the contract version of that test with the real web connection suddenly starts failing, that flags up that maybe something has changed at the other end or something has gone wrong at the other end. So that's what I wanted to talk about in this video diary, really. It's just to sort of maybe illustrate with a slightly less trivial example how working outside in, using test doubles, stubs and mocks, and solving one problem at a time can lead us to a design that is very modular, highly modular, if we're doing it in a disciplined kind of way, and tends to lead us therefore to code that is highly unit tested, because in order for it to be highly unit tested, it does need to be highly modular. But also code in itself that is very, very flexible. Now, there's all kinds of ways we can compose this code to do new things, not just stubbing and mocking. So there you go. That's how outside-in development can kind of naturally lead you to more modular code. It doesn't necessarily have to, but if you do it in the way that I tend to do it, working from the outside in, solving one problem at a time and using stubs and mocks as placeholders for other parts of the design, you tend to get led towards a more modular end result. Anyway, that's today's video diary, a slightly extended entry with a bit of code to look at. I hope you are well. Who knows what's happening now? There's a light at the end of the tunnel, hopefully. So maybe, I'm sure this will go on for a few more months, but at some point things are going to start getting back to normal, and whatever that means. And we all look forward to that as much as we all look forward to whatever kind of Christmas we're going to have soon. But I'm hoping I'll get another couple of video diaries entries in before Christmas. So please look out for those. Ring the bell if you want notifications, or subscribe to keep up with this channel.